Oh, hey. I am in the middle of a match. I'm trying to figure out what one to use. Here, what do you think? Sorry this one took me like an extra week to get out. You're probably wondering why. Why did it take so long?
Is it your fault? Is it your fault?
Hello and welcome back to Unlocking Unreal Engine. Last time we went ahead and we set up this door, however, it still had the same problem we were trying to solve where we added that giant box collision and it was picking up inputs from everybody in range. We don't want that. We want to start implementing something called a line trace by channel. So that way we can shoot out a line forward. It will see what we're looking at. And if it detects that it does implement the interaction interface we created, it will then send it a message and say, hey, you've been requested to do your thing. So to make that happen, we're going to add the instructions that we need to the pawn the player is going to be controlling. In my case, we are still using the first person blueprints, first person character. Or I guess technically I lied. The box component we added last episode was actually on our pawn instead of the door, which we are no longer going to use. So I'm going to go to the event graph. We're going to grab all the code that has to do with that and press delete. Then I'm going to click back on the box component and I'm going to press delete. Now, if yours just deleted a whole bunch of stuff and now you're confused, it's all messed up, what just happened, whenever you go to delete it, make sure it has no children. Remember what children are in a hierarchy? I think we covered this. See how there's a first person camera here and it's got the arrow? And then a little bit more indented is the first person mesh. That's because the mesh is a child of the camera. So it makes sure this has no children. And if it does, just drag them out and we will delete that and we'll hit compile and save. And now we will actually interact in a way that makes sense by using a line trace by channel. All right, so let's head to the event graph. And before I do this, let's explain what we're doing so you know what you're working toward. We want to draw a line from our eyeballs to a certain amount forward. So that way, it takes into account whatever it is we're looking at, and it will check. It'll say, do you implement the interaction interface? Which is a good way to just say, are you interactable? And if it is going to send it a message. So that's what we're doing. In order to do this, we are going to create something called a function. A function is a lot like a custom event, which if you remember in our door system, we created our own custom event called open door. And then we had that called whenever it received the interact request. The request comes in, it runs the custom event of open door, the door opens. A function is going to function rather similarly. However, a function can require an input and an output. And you're probably wondering, what the hell is that? I just realized my mic might have been peaking. I hope not. Well, let me go back to the first person character and we'll create the function and then I'll show you what an input and an output is. On the left-hand side, you'll see that there is a category called function. I'm going to hit the plus button and we'll get a new purple thing here and it says new function. I'm going to rename it on the left-hand side here. If yours is not currently being renamed, just simply select it like this and press F2 and you'll be able to rename it. I'm going to go ahead and call this line trace because we're going to be doing a line trace by channel underscore first person. So we're giving it the qualifier of first person, so that way if you need to call this function to do a line trace, it will already have the math involved that will make it from your eyeballs. Now let's go back to inputs and outputs for just a moment. I'm going to click on this function. On the right hand side, you'll see we have something called inputs and something called outputs. If I click on inputs and I type in range, for example, you'll see that it starts out as a Boolean, which is a true or false statement. What we're going to do is we're going to open this up and we're going to change it to a float. A float is essentially a number and it doesn't have to be whole. Let me give you an example. If you take a look at my calculator here, 5 is an integer or a float. However, 5.1 is no longer an integer, but it remains a float. So a float involves anything that goes past the decimal point, whereas an integer has to remain whole numbers. So whenever I did line trace first person and we required the input of range, let me show you what happens when we go to the event graph. If I drag that line trace onto the event graph, notice the target, a function is almost always going to have a target, don't worry. Most of the time it's going to remain self, so don't panic. But the point is, now it also requires a range. It's saying, hey, if you want this to run, I'm going to need the target, which is going to be self, and I'm going to need a range. It's basically saying, hey, this function, in order to function, needs this information. So you require it as an input. Now, if we were to add an output, so I'm just going to go ahead and create like a Boolean for now. We'll just make it like a Boolean, and I'll just name this hit or something because we're going to end up deleting this, just so you know. We're going to hit compile and save. And now we have an input and we have the output of hit. If we go to the event graph and we drag that function out, now you'll see that it requires target and range as an input, but then it returns whether or not hit was true. Now, if you're brand new, this might seem confusing or unnecessary, but I promise you, as you grow and you start to see what we're going to use it for, you'll understand why it's important. In fact, what I'm going to do now is create a variable. Now, what is a variable? A variable is basically a set of information that could be anything. So let me give you an example. On the left-hand side, if we go down to variables and I hit plus, and we just make this open, for example, now we have an open variable that's a Boolean. So it could be true or false. So therefore, we would have the information on whether or not, if this was a door, I know we're in the pond, but if this was a door, we would know, is the door open? Because we have a Boolean that is now storing that information. However, we're not going to use the open Boolean. Instead, I'm going to rename this to reach length, and I'm going to change the Boolean to a float. So, why are we doing that? Well, let's say we go and we set a reach length for the player. What we can do is, see this reach length value on the right-hand side? If you don't, it's because you need to compile and save first. If you ever add a variable, in order to actually manipulate the variable, you need to compile and save first, just so you know. So what we're going to do is we're going to create the length in which the player can actually interact with things, pick up things, their reach length. I'm going to pick a random number that is just off the top of my head because I've used the engine for a long time. I'm going to go with 300, and we're going to compile and save. Now, you might not understand why I picked 300, but the more you use the engine, the more the ranges start to make sense in your head, and you'll start to be like, oh, okay, I know roughly what this range is. So don't worry, 300 is an arbitrary number based on experience using the engine. So why did we make the reach length? Well, if I pull out my line trace by channel, like the function we created, which by the way is not complete. If you're like, wait, are we done? No, we're not done. However, remember, it requires this input. Well, now, anytime we have something that is directly related to our reach length, we have a variable set up that we can plug in, so that way it will be our reach length. And the reason you do it this way, because if we were to unplug this, I could plug in 300 right here and hit compile and save, right? And then this will always run 300. Well, imagine you have, like 6 or 7 different functions that require your reach length. If you go to edit your reach length or whatever, you have to individually go through and find every reference. But with this, if we had, a bunch of different uses for reach length, all I have to do is change this number, so 250, and now every function that's using reach length is now down to 250. I hope that makes sense. This also could be for things like power-ups. Say you get a power-up, so you're picking up stuff further away. Well, then you just update the reach length to like 1,000 till the power-up's gone, then back to 300. All the new topics should be mostly covered, like the big topics. Let's do small calculations in our new function. So I'm going to open that function up. We're going to go ahead and just click on the return node and press delete. And then on your line trace by channel, if you have it selected on the right, there should no longer be an output. Okay. So I'm going to right click and I'm going to type in line trace by channel. Now there's a multi and there's a regular. We just want the regular. We're going to plug that in. And because of your newfound knowledge, you know that everything on the left here is indeed an input. So we needed to let it have some information in order to run this. Now, just so you know, just because inputs exist, it doesn't necessarily mean it has to be filled in. And the reason I say that is because, like, for example, actors to ignore, we're not going to fill that in. Draw debug type set to none. There are certain times where an input isn't required, and that'll just come with experience, and you'll just have to play with it regardless. Let's take a look at the things we are going to fill out, though. We have a starting point and an end point. Remember, we are drawing a line, so we need 2 points in space in order to draw a line. You can't draw a line with 1 point. It just doesn't make sense. So we make 2 points, and then we say, hey, did you hit anything when you drew the line from point 1 to point 2? So let's do the starting point. We want the starting point to be our eyeballs. So, you know what makes sense? The camera. On the left-hand side, if we pull out the first-person camera, we can then pull out of this and type in get world location. Okay. So the reason this is going to be our starting point is because we want our eyeballs to be where it starts. Well, wherever the camera's at is our eyeballs. So our first point is simply the world location of the camera. And we can plug that straight in to the starting point. Now you're going to notice I'm making some room here. And that's because getting the end point is a little bit more difficult. We have to get a set of math done in a specific order to get the end point. And don't worry, I'm going to teach you that order and why we're doing it in that order, so don't panic. The first thing I want to do is out of the first person camera, we're going to get something called a forward vector. So if I type in get forward vector, we now have the direction the camera is facing. Now, you might be wondering, what is a forward vector? Aside from the fact I probably look like milk now because I'm pasty and white, I can show you what a forward vector is. Now, this graph shows a little bit more than I would like it to, because a forward vector goes between 1 and -1 on both the x and the y. And you can see right now we're at 0, 0. We're actually going to use this graph to explain the whole thing. So just accept that we're at the origin point because we haven't created anything yet, right? Anyway, what is a forward vector? They go between 1 and -1. And the way that it works is, let's add a second point. If on the x it's 0.71, and then on the y it's like 0.34, okay? And we press enter. You can see it created a second point. Let me label it. Well, if this is a top-down perspective, you now have the direction the camera's facing because it returned 0.71 and 0.34. And this can be any number between 1 and -1. So if this was -1, so -1 and 1, for example, when we press enter, you'll see that the point is way up here at the top left now. And now we have a direction in this direction. You can see how we can get every single direction by both numbers being between 1 and -1. So when it returns this, it can easily detect the forward vector because it's looking at it from a top-down perspective. To make things easy, I'm just going to set these both to 0.5 because then it gives us a nice angle that's like pleasing to look at this direction here. So for right now, don't worry about this number, this red number. Just understand that that's what the forward vector is returning. It's not returning 0.5, 0.5. It's returning any number between 1 and -1, depending on which direction the camera is facing when the function is called. So we get the camera and we get its forward vector. This is going to return any number between 1 and -1 on both the x and the y, so we have a direction. However, now we need a length, okay? So we have a direction, but we don't know how far to go. Now, I know what you're thinking. We have range here, so we do have a length. And you're correct. So if we take this number, so if I take this and multiply it, and yes, it is multiplication. And the reason it's multiplication is because, remember, the numbers are between 0 or -1 and 1. So we have to multiply it to actually get the distance. So for example, see how this is a vector, by the way, which a vector is 3 numbers. So we have x, y, and z. So this is a vector. If you just take this and you plug it into the bottom, it will switch to a float for you. So now we're taking those numbers. So like, let's say we go back to here. We take those numbers and we multiply them. So this is 0.5 and 0.5. And we multiply them by 300, which would give us 150, 150. So if we did 150, or here, I got to put it in parentheses. If we did 150, 150, and I pressed enter, and then I label it, and then I zoom out, all of a sudden, in the same direction, we now have a point 300 units out. Now you're probably thinking, how is that 300 units? Because you just cut it in half. It's 300 units because you have to remember that we're taking this in 2 directions at the same time. This is 300 units in that direction because we're going in a diagonal. We're not going forward, we're going in a diagonal. So it's still 300 units. So now we have the origin, 0, 0. We have a direction and a length. So now we've drawn a line in this direction, 300 units. However, we're not always going to be at the origin, right? If we're the camera and we've been playing for a while, we might be right here, which means that this number needs to be like up here with the camera, right? Not down here at the origin. So in order to do that, we're going to take the number we have, the forward vector multiplied by 300. We're going to take it and we are going to add the world location of the camera. And now, sorry, I just like to try to keep it as organized as possible. And now we have the end point. Because if we go back to the graph, this calculation is now always going to happen wherever the camera is located. Instead of 0, 0, we can literally get rid of the origin. We could literally label this camera if it would let me, but it's not going to let me. You can now just assume this is the camera. So no matter where this goes, if we were to get a forward vector of 0.5, 0.5, it's going to immediately shoot out the second point right here. Now, obviously, if we turn, we're going to get different forward vectors, which is going to make it rotate around the camera. And that is how we do it, baby. Which, by the way, technically the forward vector does put a third 1 to -1 for the Z. So that way it has that like 360 like up and down tilt as well. But I thought that would complicate things. But understand that the third number does calculate, if you're looking up or down. Starting point, our eyeballs, end point, get a direction, choose a distance, put our location in, end point. Now what we're going to do is we're going to right click on the graph and we're going to type in return and press enter. It'll give us that return node back. Plug in the execution pin. And what's cool about returns is you can take the out hit and drop it on the return node. And you can also take the return value, drop it on the return node, and there you go. Compile and save. So as you can see, what we've done with this function is we basically said, find my eyeballs, go 300 units. Then if you hit anything, return whether or not you did, which is what the return value is. And if you did, return the out hit, which is going to contain information of what we hit. So we're going to add another thing on top of this. So this one's dense with information and I apologize, but go to the event graph, drop your function onto the graph. And you'll see, of course, you know what these are now. We have the input of range and the output of out hit and return value with this function. However, I'm actually going to click it and I'm going to press delete. And we're going to go back to it and we're going to change another value. If you click on your function, the purple node here, on the right-hand side, there's something called pure. I'm going to check this and hit compile and save. The difference between a normal function and when you label it pure is whether or not it's changing information. So in this case, it's not changing any information. It's purely sending a line out, seeing if it hit anything. So because it's not changing any information, we can assign it as pure. Why is that important? Why does it matter? Let's go back to the event graph. Remember, it was that blue thing and it required input and it required output. Well, if I pull it out now, look, it no longer has an execution pin and it no longer has a target. It's just saying, hey, give me a range and I'll give you some information. Now, if this was changing something, like if we had a variable in here that was changing, we would not be able to make this pure. But we don't. There's no changing information, so we can make it pure. Okay, so we got all that set up. Now, what are we going to do? Well, let's set it up so now we can press the interact key and it will shoot that line out. If we right click on the event graph in the pawn that needs to have the input, we're going to type in enhanced input. Remember, there are values and there are events. We want the event, so we need the interact event. So whenever they do the interact event, which for us, at least for me, I put it on F. So when they start, remember, triggered makes it rapid fire. We don't want that, so we can open this up. Whenever it starts, we are going to do a line trace, which, by the way, I just realized we can't technically do that. Go ahead and pull the function out onto the graph. There we go, like that. So then let's open this up for a sec. Oh God. So what we're going to do is we're going to take a Boolean or a branch. So press B and click. On started, we're going to plug straight into an execution branch. We're going to move this over. Oh, I didn't mean to do that. I didn't mean to do the second branch. We're going to take this return value and plug it into the branch. And if you right click on the branch and the node comment, did we hit anything? So what it's going to do is it's going to take this range, send the line out, and it's going to return if we hit anything. And the reason we do this first is because if we didn't hit anything, there's no reason to continue. So did we hit anything? And remember, we do need to plug our reach length into the line trace. And I'm going to put it like right there or something, which remember, reach length is set to 300. So did we hit anything? Well, if we did hit something, we need to see information on what we hit. So anytime there's a blue node, it's a structure, which means it's a set of information. And what you can do is pull out, and there should be break. And if you don't see break, just type in the word break. And you'll see break hit result. And if I click it, here is the structure of information that it received whenever it shot out. It's a lot. But luckily, we don't need all that. We only need the hit actor. So on hit actor, pull out, and you're going to say, does implement interface. Click. And once you've done this, you can then hit this arrow to recollapse it, and it's way smaller. The interface we need to know if it's implementing, remember, is BPI interaction. Then we can press B and click for a second branch. So if we hit something, now we're going to check and see, is it interactable? And we're going to right click on the branch and say, is it interactable? Shoot the line out. We hit an actor. Is it interactable? If it is, we can send it a message. Remember what interfaces are? The envelope, you send a message. So we're going to pull out and I'm just going to type in interact. And you'll see that our BPI interaction, interact request message, pops up. However, it needs a target, but remember, we have the hit actor here. So we can take this, plug it into the interaction request, and we get this ugly line that goes through everything. So if you double click on a line, it'll add pins to it. So we're going to add some pins to make this easier to follow with our eyes. And it's just more pleasing to look at. There we go. So now I'll hit compile and save. We press F. We do the line traced first person with 300 length. We check and see if we hit anything. If we did, great. Does that hit actor implement the BPI interaction? Because if it does, we need to let it know that we're trying to interact with it. Now I'm going to grab this. I'm going to press C. If yours goes away, just hit F2 or just click on comment. And what I'm going to do is I'm going to type in input action interact request. Then I'm going to show bubble when zoomed. And then if you zoom out, you can easily, quickly find your input action for interacting. And you just did a pretty complicated set of code for a beginner. So if it makes sense, this is why I like you. You're doing great. I love all of my viewers. Seriously, I like you because the fact you're watching me means that you don't like things to just be fed to you. You like to understand it. You like to actually break things down. I like you. And now let's see this in action. Let's compile and save. And I'm going to go back to the first person map. I'm going to hit play. So remember, if we did this correctly, when I look at this door, it's going to shoot a line out 300 units. And if it hits an object or an actor that contains the interaction interface, which we know the door does from last episode, it will tell it, hey, we're trying to interact with you. But notice if I look away, hold on, I forgot, this doesn't have close on it yet. We'll get to that. But let me reset it. If I look away, look, it doesn't interact. But if I look at it, it interacts. You are doing fantastic if you've made it this far and you still understand what's going on. You're doing great. I love all of you. Seriously, you guys decided that you wanted to take the harder route and actually learn this stuff. So props to you. Please like, comment, and subscribe if you're enjoying the series, and consider donating to my Patreon so I can continue to bring these great videos. It's been an honor, and I'll see you in the next episode.